Otherwise, you're gonna see me. You're gonna like go and actually watch this thing, and it's just gonna be like a blank or the same screen over and over again. But I'm pretty sure I got that one right. Okay, so as I was saying before, in our lecture review on lesson 5, um, there's this idea of the model view controller, the MVC paradigm. Pretty much, it's not a standard by itself, but it is a way to conceptualize what's happening. So we looked at the we looked at the controller and the view. The database is what actually makes up the model. So when that's where the data persists. The controller accesses the data from the database, passes it on to the view, and then the view gets passed on to the user. So that's today, the model part of it. We're not actually going to do too much modeling, but you guys are going to get familiar with the very basics of databasing. So yeah, and there we go. Relational database basics. That's what our topic is for today. And we're going to talk about ORMs, object relational mappers. So that's a real nice, easy way to handle databases, because I got to tell you, I don't enjoy it that much. People are all high on SQL and all this kind of stuff, and it's like, well, why would you? You got ORMs. That makes life so much easier. And when you're a programmer, easier is better and faster, because we're also impatient, and we also like to show off. So if you go fast, and do it easy, then all 3 points are covered. So we're going to create, when you guys get to your Finstagram, you guys are going to start creating posts. So up until this point, you've been wrapping them in hashes and passing them back in arrays. That starts to change as of today. That's not really the way we do things, right? Because we want to be able to add as many posts to our Finstagram application as we want. And I mean, you're not going to go and change the code every single time you do it. You're going to write the code once, add the content, and store it in the database. Come look at it later. So what is a relational database? Everything's collected in a database on the, I don't even know what you call it. We just call it a database. We got these two weird synonymous terms here. But we'll have an illustration following this slide concerning tables. And I mean, you've all been to high school. You've been all to all this kind of things, like we organize these tables in rows and columns. You got the column header, and you put the values between it or underneath it, and every new row is a new record in your column. The best way to illustrate this, I think, for most people, is an Excel spreadsheet, which will be illustrated in just a second. There we are. So this isn't too far off. Now, Excel isn't, well, this isn't actually Excel. I think this is Google spreadsheets, because why would you spend money on Excel when you can get Google what they give you for free? To me, that's mind-blowing, but people still do it. You can still go buy the Office suite for $600.
My parents do that.
That's crazy. They're living in 1992.
I buy every time.
It's nuts.
I did one Windows Professional or Office Professional.
No, it's a waste of money. I maintain that. But here we see all these elements. We see the table, we see the row, and we see the column field. So here are the columns. Each have their IDs. And this should bring back memories of what you've been doing from last day, where you've been creating those hashes. These actually are probably the exact same, if I'm not mistaken. You had a photo URL, you had the user ID. You might not have had created at or updated at. This is some stuff that most databases do for you automatically. But you assign these tributes just like key value pairs. And each one of these rows, in this case, is a different entry in your post table, presumably, just because we know from Finstagram that's the example that we use for this course. So imagine a hockey application. How would you model that? We got a couple of tables here, and you can carry this to any extent. Well, yeah, take this hypothetical team, and just this might seem obvious, but let's have some class participation here. What fields might a team have?
Games played.
Games played. Well, we actually have a games table. So this is kind of where it's going, right? How about city?
City.
Sure. The name? Absolutely. We're going to have players, and that team field is going to have some way to, or sorry, that team table is going to have some way to accommodate an ever-changing roster, right? Because, every time there's a draft, every time there's a trade, something's going to change. So we have to have some way to link up the players, which each have their own table, each with their own record. We have to have some way to connect them to the team table. Likewise, we have to have some way to connect the games because, just like what sports is, I mean, very statistics intensive. Hockey's not a perfect example of that, but look at baseball. I mean, they collect stats on anything or on everything. And their gameplay changes accordingly. We're just getting into hockey, incredibly. I met, he was the assistant coach for the Canada Olympic team in Sochi. They go and win. Was it Sochi the last one around? He went on to win a gold medal. He actually used to live in the townhouse complex right behind me. Met Cassie Campbell, met the dignitaries from Hockey Canada. They're just starting to get into this. I can't believe it. And Canada is the best at hockey for a reason, and yet we're kind of just primitive in this way, right? It's crazy that baseball's got it nailed, but hockey doesn't. But yeah, some way to take all this activity in the league and model it and connect it and make it relate. So let's think about Finstagram. What tables do we have? Posts is the obvious one. What else we got? Users, comments, likes. So how do we connect all of these different tables? And is there any other ones? That's 4 for sure. Somehow we got to make it known that a post belongs to a user and that this post has all these comments, and then each one of these comments was made by a user, and that with this page or this post is liked by certain users. And then somehow we got to make it sure that a user can't like the same post more than once.
Timekeeping as well. It's another part of that.
This one, or on the hockey app. Sorry?
On Instagram.
Time.
The table is dealing with the time frame.
Oh, okay. We got to look at Instagram again. Okay. And so each of these different tables, now we've talked about a few. We've talked about likes. We've talked about users, posts, and columns. Pretty familiar with the post table. User ID is definitely going to have, say, your online handle. It's definitely going to have an email. What else might it have?
Your likes.
Well, likes is a separate table. Password, for example. Likes. Probably only really need 2 things. You need some user ID. You need a post ID. And that might be it, I think. Anything else? Can you think of anything you might need? What about comments? Somehow you got to get the comments connected to the post. Comment has to come from a user. The comment might actually have likes itself, right? All sorts of things to consider. And this is what we talk about when we talk about a relational database. The database itself and these tables have no knowledge of each other. The only connection they have is that we keep IDs of, say, the user, for example. We keep a user ID in the post record, so that we know that post, when we look it up in the database, belongs to that user. Same thing with likes. Say probably either a post ID or maybe a comment ID of some sort, and those are the only 2 IDs in the likes. Seems like I'm missing something there. But somehow we have to establish these relationships between these individual tables. Otherwise, this just disorganized information. It's just chaotic, right? We have to impose this order upon it. So, now we skip ahead here. So how do we talk to the DB? the database. So you've been introduced to a few things, just kind of, surface level stuff. You might be new to the integrated development environment provided to us courtesy of Cloud9. You might be new to server. So we develop in this environment, which is basically just a glorified text editor. We install new software in our bash command line, which is the operating system. So right there's two things: the operating system, the IDE or a text editor. What else do we need to make a web application? It's a big one. Server. Right? Somehow we got to put this up. We have to tell the operating system to open up a port, and whenever some sort of external software comes along and makes a request, listen for that request first of all, and send it to this piece of software. So we got, even then, an intermediary. We got what we call Sinatra. And when I say Sinatra, it's this thing here, the thing that was giving us so much trouble. We downloaded that configuration, and Sinatra provides us that bridge. So we're stacking technology on top of technology. Now with the database, that's just one more thing we're adding to this pile. We call it the tech stack. Some very popular ones. What's the most popular right now? They usually have cutesy names. I'm trying to think of a good one here. Mongo, Node, Angular. It's usually the technology to serve it. Okay, never mind. Let's not worry about it. All that to say is that there's a lot of moving parts here, and we're adding another moving part. So how do we talk to the database? Because these are two separate pieces of software, and separate even from the web server itself. Through that, we use an adapter. And we have this nifty little piece of software called the Object Relational Mapper. So now remember that Ruby is an object-oriented language. What this Object Relational Mapper does is it makes our database records look like objects. And it establishes those relationships. Because remember what I said, there is no relationship between the tables in the database beyond those IDs. We call them foreign IDs. Beyond that, they have no idea about each other. It takes something like this, the ORM, to establish those relationships and make it easier to manage for the developer. And it is a lifesaver. You don't have to do so much SQL. And you guys are kind of familiar with the hash. I mean, as familiar as I'd expect beginners to be. This acts a little bit like that, in that you can index or call methods on it. So you could say user.name or user.email and retrieve that data without having to say select star from user where user ID equals whatever, right? That's SQL. Makes it a lot easier. Active record is the ORM. It's not really, not a standard, but it is very popular. It's very popular in Sinatra, very popular in Rails, to the point where there's really no advantage in using anything else. And I'm speculating here just a little bit, but I think that this is probably the biggest one in the Ruby community, and possibly beyond that as well. And what this does, because as I said, everything's got some cutesy name: create, read, update, and delete. What else do you want to do? You want to create a record, you want to get it back, you want to read it out, you want to change it. Maybe the user changes his email. Or the user decides, okay, well, I'm sick of Instagram, I'm going to shut down my account. There's nothing else to do, right? Create, read, update, and delete. We can do all this stuff without Active Record, but Active Record makes us a breeze. So first thing we're going to do, and this is more demo oriented, so I'm just going to kind of rush over top of this. But when we create a table in our database, remember, there's the database, there's the table, which contains rows and columns, and each row is a record. Each row becomes an active record instance, an object that we can call methods on. We create a model. This is the model part of the model view controller, and we do these CRUD operations. So here's a create example. I say user, I want to make a new one, so I create, pass the username, pass the basic details, and then that object, not only does it get created in the database, it gets returned immediately to this variable, and we can do whatever we want to the variable. We could maybe make it an instance variable and display it on HTML in our embedded Ruby, ERB. And of course, there are analogous operations. There's not something we call read overtly. We actually we use a couple of different methods. We could say find or where, but we have a whole bunch of different methods that allow us to read back from the database. If we want to update something, it's as simple as saying, well, sharky.username now equals Dan. Then we say sharky.save, and it changes, it updates the database. We want to destroy it. I actually think it is just delete or destroy. We'd say sharky.destroy. All right. So this is going to be the demo part, and then you guys are going to go off and do this for your Finstagram. So as always, in preparation for this class, I created just like a bare bones project from this template I've created. And again, I please invite you to do it. Tell me if there's any problems. If you get really ambitious, you can even update and improve it. But it's there. I created it just so I can do these kind of things. Do it really fast. Just get a demo up and running, and show it to the class. So I'm going to make a very simple to-do application. Like I've got a list of things I want to get done. I need to organize this data. I need to be able to add this stuff. So, create it. I need to be able to read it back so that, I can look at my phone and say, okay, well, shoot, I got to go to the store. I don't really need to update these things. Really, if I'm doing a to-do list, I would probably just add a new to-do and delete the old one. But there you go. You have all those operations. And when we get into the next week, we'll create the interface for that. But today we're going to do the database stuff. So now when creating a database, especially with Active Record, we work with what are called migrations. Now this is just plain old Ruby. There's nothing special about it. We call some methods. We call this from the outside. And what it's saying to us is, let's create this database and let's put these tables inside of it. Now this is a very simple migration. Migrations really, their power really becomes evident when you're developing a large project and you decide, oh, my table, I don't have enough columns in my user column. I need to add a street address or something like that. A migration allows me to do that, try it out, and then I have the option of rolling back if for whatever reason it doesn't work out. That's why we use migrations. So this is a hypothetical users table. Now I'm going to do to-dos. There's a lot of weird little things about this that takes a long time to get used to. But when you're creating a to-do or a table, you make it plural. This is one of those opinionated things. Remember, we said that software development is opinionated. Active Record, has certainly adopted that philosophy as well. So you do it the Active Record way, otherwise you will be punished when it comes later you try to do something different. So I'm just going to change this around a little bit. I'm going to call it to-dos, make sure it's plural, and then I'll just make, I'll call it something different. I'll call it, here's my task. This is what I need to do. This task is going to be of type string. So remember those various types that we have. String, integer, floats, and booleans. These are all the same kind of types. These are kind of common types across computer technology. No matter where you go, you're going to find at least these types. So I'm going to create a task. I'm going to maybe assign it, let's say, priority. I'll just make that a string as well. We're going to keep this a really simple example. So, for example, we could say high, low, or medium priority, right? Maybe there's just three levels. And we're going to have one to tell me if it's complete. And I'm going to set a default value, and you can do this, right? You can change. You could do this to the task as well. So every time you create a new value, you want to have something in that table or in that cell in the table row. You can set this default value like this. And I'm going to say false because, the first time I'm going to do it, obviously it's not done, right? So very simple. One more thing to note is this timestamps. And what this does is just does a little bit of magic so that it gives you 2 extra columns in your database table. Created at and updated at. So created at basically never changes unless you go in there and change it yourself. Updated at changes every single time you call save. Maybe you added some new information, maybe change the priority on your to-do. You would say save this task, and that column updated at will change to the moment that it was saved. So there's our very simple database. It only consists of one table. We could put as many as we want. Instagram, I think, has at least 4. And when we get to this point, now we use a rake task to actually make this thing. Now we're using we call it a development database. It's called SQLite, or some people call it SQL. I don't know why I find that obnoxious, but basically everyone except me calls it SQL. And the other thing is weird. Sorry, this is just an aside, but how come we don't call URLs? How come we don't call them URLs? Right? That makes a lot of sense, but no one says URL. And when I say URL, no one knows what I'm talking about. But then it's like people say SQL, and it's like, I guess I can kind of see why. I don't know, whatever. Those should be called URLs. Maybe I'll just start doing that and see if it catches on. All right. So where was I? Oh, yes, we're going to actually create this database. And so all the database stuff actually happens in this database folder. And this isn't unique to Sinatra. This is also the way Rails does it. So if you are, you come to the end of this course and you want to learn more, Rails is the next logical step, I would think. You'll have that kind of a feel for the environment, the feel for the tools. It'll be a lot easier to learn now that you've taken this introductory web development class. But watch what happens. I say rake, actually I think I have to do bundle exec rake db create. Now if I did this right, and I didn't make any mistakes here, you're going to see a file appear up here. It's doing something. Oh, there it is. You see that one? This isn't actually how databases work. There is certainly that file system aspect, but it's different than that. It's a lot of the data managed by a database is stored in RAM, like memory, so that you can access it quickly. SQLite is for development purposes primarily, and since it's a file, basically only one user at a time can read it. So when we get to the point you guys have been committing all your stuff to GitHub, week 6 we'll be able to take this and put it into a production database we call Postgres or PostgreSQL. Another very popular technology. So for our development purposes, this works just fine. I've created it. I actually haven't created the table inside of it. At this point, there's no to-dos, I should say, no to-dos table. So to do that, I type in migrate. Now this is going to be all inside of your course material in Compass. If you ever do need a reference for whatever reason, I've got it noted here as well. So this is just my skeleton project that Right? Please use it. So I say rake db migrate. It looks inside this migration folder. It picks the very first one at the top, and it executes this code. So now you can't really see it. Well, we can. Maybe I should show you. But there in SQLite now is a table, and there's that data structure that will let me perform queries. We're going to perform our queries through Active Record rather than straight SQL. Now, let me see if I can remember how to do this. Just for the purpose of demonstration, I think I should be able to do SQLite 3 help. Let's see what's in here. So now I'm talking directly to the database. Got a whole bunch of different commands I can call on it. Oh, here's a good one. Let's see what databases I actually have. Say .database. And each database management system has its own command line interface. So this is the SQLite one. Doesn't look like I have one. That's kind of concerning. Well, let's see how far it will take us. All right. I know I did the migration. I know it was successful just because. Where did it go? Because this was actually where the migration happened. There was no errors. If there's an error, it's going to tell you, and it's going to blow up, and you're not going to be able to miss it. I know there's something in there. This is just me being naive about SQLite. I don't do this day to day, nor should you. It's crazy. Why would you? You've got ORMs. Okay, so now we're getting to that ORM component. We need something in our Sinatra app in Ruby that is going to take all the properties of Active Record and make it so that I can do to-dos or to-do.task, or give me all my to-dos, something like that. To do that, I need to create a model in my model file, my model folder. And you name it the same thing, except you do it in lowercase and you don't pluralize it. It's kind of funny that way, right? It's very picky. You got to know when to use an S and when not to use an S. So I call this one to-do RB, not to-dos, just to-do. I open that up, and I just need some very simple code. Nothing complex. I create a class. So this is object-oriented stuff. We haven't done really any sort of inheritance and child and parent class kind of stuff yet. But this is how I declare that. So here's my to-do. Begins and it ends. You open a block with an if, with a def, whatever, you got to close that block with an end. The class definition is no exception. But I need something else. I need to take all of that functionality offered to me by Active Record. And I do that through inheritance. So here's the Active Record class, and Cloud9 is trying to help me here. And I take the base class. Don't really need to know what's happening here. You can spend, a whole university semester in computer programming and not really understand what's happening here. I know it took me a long time to fully grasp object-oriented programming. But what we are doing is we're just taking a parent class. This is one that's got a whole bunch of different methods, a whole bunch of different functionality. We don't know what it looks like even. But I do this little less than sign, and all of a sudden, to-do can do the exact same stuff. It's called inheritance. Child inherits the traits from the parents. Okay, so there's our model. Whoopsies. I don't know how that happened. Come back here. Let's get rid of all that stuff. Okay, trying to save my file. So I'm going to start playing around a little bit here. I want to add a couple of records to my database manually. So we're not going to do a web interface yet. We're just going to do this hands-on. And we use a program called Tux, which was installed as part of, installed when you called bundle install. This is one of the requirements in your gem file. Tux is just like IRB, except it does a little bit of stuff behind the scenes in that it's sort of made for loading up all the dependencies in a Sinatra app or a Rails application. IRB, for example, wouldn't it wouldn't load this active record model. It looks at my dependencies and it does all that for me. So now I can kind of treat this like a mini Sinatra application. IRB by itself won't let you do that. Tux is built on top of IRB, or at least I assume it is. So let's take a look what's in to-do. So here's our class, the one I just declared, and I want to find out what's in it. The easiest one is just to call all. Here I'm going to keep my fingers crossed I didn't do something silly. Oh, there we go. This is what it returned. It's definitely an instance of an object, but you can tell just by this guy here that, well, it looks more like an empty array. I haven't actually made any to-dos yet, so let's make one. I say to-do equals to-do.new. Brand new to-do. And you see a couple of things that you should be familiar with because we define these in our tables, in our migration. Here's one you haven't seen, an ID. Every database record has a unique ID. That's one that got created for you automatically. The task, this is one we did. Here it is right here. It's nil. Nothing's in it yet, right? I just created a new object, but I didn't actually put anything in it. I did my priority, which we know is a string. Complete. Remember, I set a default value. There it is. It's false. And I did the created at. Well, this isn't actually going to get set until I save it. So let's try to change this around a little bit. Let's let's set these values. So I've got my empty to-do object. Here it is again. Whoops. There's my empty to-do object. What I can do is I say to-do task equals pick up Xbox 360 games. Okay, that's what I have to do after class today. All right, so I look at it again. It's changed a little bit. So this is a lot like a hash. You see it there. The task now has the Xbox 360 games. Priority, it's well, not high because I need these games or anything, but I said I'd go do it, so I better go do it. I'm just going to type in high like that. Again, it changes. Nothing else we can really change here. I mean, we could say that we completed it. We could set that to true. We could even set this value. I'm going to tell you right now, don't mess with the ID. You never change the ID. You have no need to it, and you're like committing the cardinal sin of database management if you do. I also don't need to set these. I could if I wanted to, but that would be silly because then why would I have use that timestamps thing? I want the database to take care of this stuff. So I'm going to take this object that I just created, set a couple of values, and I'm going to save it with that save method, to-do.save. There we go. So now watch how it changed. When I look at the inside of it, all of a sudden ideas has a value. Now, SQLite is a very primitive database. It just starts counting at 1. That's fine. The next record I add, it's going to count at 2. It's got my task. It's got my priority. It's got the complete. Still haven't done it. It's got created at. All of a sudden, I've got this timestamp. Kind of neat, right? Just does that all automatically for you. This, to me, we were joking about what morning when I first came in here. I think that actually is Greenwich Mean Time. I'm not entirely sure. It just kind of defaults to that, although I could be wrong. Because we're, 7 hours behind? 6 hours behind during daylight savings? Whatever. Doesn't matter.
Yeah, it's the 6th right now.
It's the 6 hours?
Not the 7th. No, it's July 6th right now.
Oh.
I'm saying it's the 7th.
Oh, yeah, so right, there you go.
We are somewhere behind.
Or at least this computer is probably somewhere, well, what time is it now? It is 6:47. That is 6 hours. Yeah. Looks like it's early morning in Greenwich Village in England. There we go. Okay, so let's just do another one. Let's do it really quick. I'm going to show you a shorthand cut or a shortcut to doing that. So again, this is on the big T. This is on the class or the model. I say, instead of saying new, I say create. You know what? I'll assign that to a variable so we can take a peek. I'll call this to do 1 because presumably to do by itself is to do 0. Now inside of create, I can pass all the parameters I want to set, and I pass it as a hash. Now, you don't actually need the curly braces, but I'm going to put them in there just to illustrate the point that this is in fact one single object, or at least it's being received that way in this method. So I say, here's my task. My wife asked me to pick up a bottle of wine. Got that. Priority, again, very high. I press enter. There we go. Returned all that stuff. Here's ID2. Don't concern yourself with order. ID is managed by SQLite. It's managed by any database management system. Don't monkey with that number. Just don't do it. Don't worry about it. Pretend it doesn't exist. So I got to pick up wine. I've got priority high. It's not done yet. Create. I'm going to do one more thing. So this is what we've got planned for tonight. To do create. Task. Watch Big Brother. My favorite show. First time I saw Big Brother, I was living in Scotland. Edinburgh, Scotland. Priority. This one's just medium priority. Because truth be told, it is kind of boring, especially in the early days. But, never been into Survivor. I saw the very earliest Dutch version. I like that one better, but the American version is pretty good too. All right. So that's what I like to watch on TV, and that's what I like to drink when I'm with my wife. So now I've got 3 to-dos. Remember how I did todo.all? I got nothing back? I should do todo.all, big T to-do. Now I've got, they're all full. So there's the start of that array. There's the end of that array. All the things I've got planned for this evening. Okay. So now we got to look at some. We got to have some way. Now here's going to be your ERB reminder kind of stuff, and we're gonna go back to the controller and the view. We've created ourselves a model here. Now we're going to make it so that we can actually access that and show it to the user. So let's come down to here, and where did I go? Views. And I've got my layout. I don't need to monkey with that. Here's my index. Okay. Let's make this into something else. We'll say stuff I've got to do. Colon. So we've got kind of the start. Just in my own kind of professional practice, this is something I sort of leave to the end. It's not necessarily the right way to do it. It's just that you usually do the models first, then you start doing the controllers, do all the testing and all that kind of stuff. The last thing you kind of do, not because it's the least important by any stretch, is the view. So I'm just going to change this around, leave it there on the back burner, and come up to my controllers, which are in actions.rb. I've only got one route at the moment. We've got one landing page. How do I get all of my to-dos?
You have to call them.
Yeah, how did I do that? I just showed it to you. How do I get all my to-dos? To-do.all. Okay, but now I call it one time, it's just going to disappear. It's going to go up in smoke. How do I get it so that... not just yet. I like where you're going with it. We're going back to the view. How do I get this stuff? How do I get this value so I can access it in the view?
T__x.
So I heard an answer back there. No, an instance variable. Remember, so anything I assign to one of these @ variables now is accessible over here to index.erb. All right. And really, I don't need to do anything else. I'm just going to look at all my to-dos. I'm the only user of this application. Super simple. Super simple. One thing I did forget, remember, go slow. I never actually did refresh this to make sure I'm not crashing anything. It's, it's a good idea just to go and do a sanity check, we call it. Oh, there we go. Okay, stuff I've got to do. So we come back to our ERB, and this is where Dan was going. He said, well, now we can access each of these values in an each. And I'm going to use an ordered list. So OL for ordered list, that just means put numbers instead of just, round bullets. And I'm going to use one of these neat alligator tags. And since I created an instance variable, I can call each, just like that. I think. Yeah, I think so. Do to do. So I'm going to look at every single item in my array. And each pass is going to assign to that to-do parameter. And inside this is where I'm going to actually print this to the screen. So we're talking about HTML here, just the basic stuff. Every new list item is an LI, just like that. And inside of this list item, I need a special alligator tag. Which one do I need? The one that prints the screen. What's the distinction? Equal sign. Yes, exactly. I got too many angle brackets there. So I just simply do this. I say to do. What's a good way to do this? We'll say to-do.task. So I'm going to retrieve that value from the to-do. I'm going to put a dash there. So now this is just a literal, string literal. It's going to get printed as I've shown it there. And I'm going to say priority. So I've said a couple of these things, right? So priority now, we're using that same instance. And I call that priority method on it, and it returns the value. So I went pretty fast here, but I think we'll do okay. Let's try it out. Let's come back to Sinatra, my browser. I refresh, and if I did everything right, I should have 3 tasks. Oh no! Undefined method each for nil class. So something went terribly, terribly wrong. And now I don't think you guys can see it, but it always gives you a helpful hint as to where the problem actually arose. I can barely see it. Number 3. Huh. Actually, a bit of a loss here. Usually I'd say, oh, I forgot to do that. Let's investigate. So it says this is wrong. To-do is equals to-do. Oh. What? Any guesses? Okay. Well, we got to go slow here. So I went a little bit too fast. Lesson learned. Okay. What I'm going to do is I'm just going to take this all out. Or maybe I should just comment it. Let's see if this works. If you want to comment ERB or this embedded Ruby, you can use a hashtag just like you do. You kind of got to be careful where you place it. So these logical operation ones, the ones without the equal sign, you just put that hash right behind the percent sign. With the ones that spit something to the screen, you got to actually put it between the two. So just something to be aware of. I've also got this one over here. I almost forgot. Okay, so now we're going to do a sanity check. I should see one list item with a dash and a priority. Unless I did something really wrong. There we go. Yeah, so there it is. One list item with a dash and a priority. How did I know? Right. There we are.
It's like you've done this before.
Well, we'll see. Yeah. Okay. So I want to see what's in this to-dos, right? Because it said that there's no each on a nil method. So I'm very curious about this because I'm pretty sure. Oh, I wonder if I forgot to save it. Can you imagine how something so silly? This happens from time to time. But let's try it. So I know it's not saved. Well, you know what? Let's investigate a little bit further. You know, I've only got 6 channels because I don't have cable, and I can watch like Murdoch mysteries like 6 times a day. You guys seen this show? Yeah. So I like, one day maybe I'll become a detective. So I'm going to do some detective work right now. All right. So I'm going to recycle one of these guys. All I want to do is see if there's something in to-do. So it's not going to look nice. It's just going to give me one of these weird looking object instant printouts. But I want to make sure there's something in there. And I didn't save it, so this should crash. Ooh, it didn't crash. But there's nothing in there. Okay. Let's go back and invest. Oh, I didn't save this one either. Jeez Louise. Try that. Okay, now let's see if it crashes. No crash. Let's come back to here. Let's save this one. So now I can see Sinatra being smart enough not to blow up in my face in that case, but now I should see something. I see nothing. That might be okay though, because there is actually something there. All right. Well, at least we're in a position where, there's like order's kind of been restored to the universe. We're imposing that order upon it. Something there. Okay, and we got 3 items because there's 3 hashtags. All right. It looks a little weird, but we know something. We know basically everything is okay. So let's take this out and put this stuff back in. There's my to-do priority. Don't want to forget about that. Press refresh. Oh, there we go. Okay, so first thing I got to do, pick up my Xbox 360 games, get some wine, watch Big Brother, go to sleep, wash, rinse, repeat, whole thing until I'm dead. And the peace of the grave overcomes me. Actually, I'm just kidding. Right? Yes. All right. So what else can we do here? I don't know. What else would you like to see? What else can I do with this to-do list?
We have another list item.
We're gonna wait till next day.
Okay.
That is that would be the natural progression, certainly. But we're not quite there yet because this is actually a lesson in and of itself. We have to have some way to get the data from the client to our server, right? So we've covered the model, we've covered the view, we've covered the controller. We're going to get deeper into the interaction between the 3 of them when it comes time to put a little form here that says enter a to-do and a drop-down menu that says priority and then a button that says, send or submit or whatever. All right. That was like the first lecture ever that ended on time. So I'm just going to stop right here and you guys can go to work on Finstagram.